Now let's see how we can solve this differential equation. And we are familiar with some of the standard forms, and let me write down that. There is one standard form which is dy by dx plus py is equal to q. I hope you remember this. This is a standard form of a linear differential equation. This is LDE. Okay, but then if you see clearly that this equation is not fitting into that form. Dy by dx plus py, there is no y. You have sine to y, and that's not how we want it. We want py, right? And also, I mean, you don't even have q, right? Do you remember the rule for p and q? Let me write down that p and q are functions of x or constants. And if you see, q is definitely not a function of x. So please understand, it is not fitting the form of a linear differential equation. It has to be something else. So we have to simplify and see what we can do. Okay. Now in this case, you have to look at this question very well. Actually, this question is very important. Okay. Exam, you will find this question, and it is sometimes become very tricky. If you don't know it already, finding on the spot how will you will solve this question is going to be tricky. Okay. So let us see what we can do. And I just want to teach you strategy rather than just the solution. You see, sine 2y, of course, I can simplify that. I can write it as 2 sine y cos y. Okay. And supposing if I divide this entire equation by cos y. So now in the solution, the first step if I do is divide by cos square y on both sides. Now, why am I doing that? Because I don't want the y term on this side, right? So let's just get rid of this cos square y from here. So if I divide by cos square y on both sides, this will become, now this term will become sec square y dy by dx. That is 1 by cos square y here. Plus this is x. Sine 2y is 2 sine y cos y, and I am dividing by cos square y. Right? And then this cos square and cos y will cancel out. And then on the right hand side also I'll divide by cos square y. So this cos square y will go away, and then I'll have only x cube. And it's a bit better than before, because now at least I have q, which is purely made of x. And that's how we want. We want p and q to be of functions of x only, and no y is allowed. So that's a good thing. But now let's simplify more and see what we get here. This is sec square y. This is dy by dx plus, then this is 2x tan y, and this is equal to x cube. Now, most people tend to forget this particular form, okay, and it is very difficult to identify in exam. So I want you to pay attention to this one and remember this really well, that if you have f dash of y dy by dx plus f of y times p is equal to q. Now, in this case, if this is the differential equation, your differential equation is in this form, then in that case, what we do is put f of y is equal to u. Now, that's the way of solving, right? What do? We put f of y is equal to u. You see tan y is a function of y. And do you see that sec square y is f dash of y? And that is exactly how this form is. Okay, so to solve this, now I'll have to put tan y is equal to u. Now we will differentiate this. When we differentiate, the derivative of tan y is going to be sec square y. Now please understand, this is differentiation with respect to x. Okay, because our independent variable is x, so we're different with respect to x anyways. So this is derivative of tan y will be sec square y, and then there'll be chain rule. I'll have to differentiate y again, and that is going to give me dy by dx. I hope you understand that. And that is equal to du by dx, right? And now this sec square y dy by dx equal to du by dx, I can use it here, and then tan y is just u. So if I change the variables, okay, as per the new format, if I get everything in terms of u, now this equation will become, this is du by dx, this term, okay, plus 2x, tan y will become u is equal to x cube. Okay. Now, if you see, now this is linear differential equation. This is exactly in this form with the different variables. Okay, so when you get a linear differential equation, the solution is going to be, finding solution is going to be easy. Let me show you how that works. Now for linear differential equation, you have to identify what is P and what is Q. The 2x value here is P, right? And the x cube value here is Q. So I have value of P and Q. The next thing I will do is I'll find integrating factor IF. IF is equal to e raised to integration of P dx. That's the standard formula of integrating factor. So you will get E is equal to integration of P. What is the value of P? It is 2x, right? So it is 2x dx. So the answer is going to be E raised to integration of 2x. Oh, sorry. We will integrate this now. So the integration of x is going to be x square by 2. 2 remains outside. Integral becomes x square by 2, right? And then the 2 will cancel out. And the final answer is E raised to x square. Now that's the value for integrating factor. This is IF over here. Now, once you find integrating factor, the next thing we will do is write down the solution. So the solution of linear differential equation is, this is y into IF integration of q into IF dx plus c. Now, this is very much the standard solution of a linear differential equation. There is just one point that you have to understand, that now our dependent variable is not y. Okay, the dependent variable over here, if you see, it is u, right? Okay, so the dependent variable is u, not y. We have to take u here. Then in that case, it's not going to be y. Fair enough. Everything else will be fine. Just substitute the values and you can get the answer. Now u into IF. The value of IF is over here, right? It is e raised to x squared. E raised to x squared is equal to integration q. Now, what is the value of q? Q is the right hand side, and that is x cube. So q is x cube, and IF is going to be e raised to x square dx plus c. Now, all we have to do is we have to evaluate this integral, and to evaluate this integral, best thing we can do is do the substitution, right? So, supposing if I put x square is equal to t, now I will get, if I differentiate this, I'll get 2x dx is equal to dt. So I've got x dx is equal to dt by 2. Fair enough. And I can always write this x cube as x square into x. And this x dx is going to be dt by 2. And x square, I can write it as t. So let me write down this answer. U times e raised to x square is equal to, this will be integration. X cube, I'll split it. I'll write it as x square into x, and x square value is going to be t. Okay. And then e raised to x square is going to be e raised to t. So this is e raised to t. And x dx becomes dt by 2 plus c. Now that's the simplified version of the formula. Now let me clear some space to solve this question further. So we have u into e to the x square is equal to, I'll take half out, integration, if I take a half out, integration t e raised to t dt plus c. Now we have to treat this as u into v, and we'll use this formula. Integration of uv is u as it is, first integral v1 minus u dash, the derivative of u, second integration v2 plus alternate minus plus sign, and so on and so forth. So this is the formula we will be using to solve this integration. Now let me rewrite this. U is equal to e to the x square on the left hand side is equal to half. Okay, this u as it is, so it is t. Then integration of e raised to t, v1, right, is going to be e raised to t. I'm basically using this formula to solve this. So minus the derivative of t is going to be 1. And another integration of e raised to t is just e raised to t. And the next term is going to be 0 onwards, right? So you don't have to solve further, plus c. Now just note one point, that the answer, this is, we've actually got the answer, but your answer has to be in the original variables, not t and u. Okay. I hope you remember that when we took u, it was a tan y, and tan y was treated as u. So let me put that back as tan y, e raised to x squared, and this is equal to 1/2. This is the value of t is going to be, let's put the t back. If you see, the value of t is equal to x squared. So this is going to be x squared e raised to x squared minus e raised to x squared plus c. I can take e raised to x squared out. So it is going to be half, or I can just say e raised to x squared divided by 2, and that will be x squared minus 1 plus c. This is tan y times e raised to x squared, and that's the solution of given differential equation. Okay, so that's how we can solve and the solution. I hope you followed this. This was the equation we were supposed to solve, and this is the answer to that one.